Hello, welcome to the final lesson in the Math 60 telecourse. We've talked about a whole lot of topics this term. We've talked about arithmetic of real numbers. We've talked about working with algebraic expressions. We've talked about linear equations and inequalities in one variable. We've talked a whole lot about application problems, and we've talked even more about line problems. One of the cool things about line problems is that if you work enough different types of problems, every single topic that we have covered this term comes up somewhere in the problem-solving process. So we're going to spend today reviewing lines. I'm going to quickly review the algebra of lines, although it's probably not going to seem so quick because there's a whole lot to review when considering the algebra of lines. Then Candace and Ann are going to follow me working some application problems to remind you about some of the issues that come up in those types of problems. So let's talk about all things linear. A linear equation with two variables, x and y, can be written in the form ax plus by equals c, with the condition that a and b cannot both equal 0. The reason these are called linear equations is because the solution set to a linear equation with two variables is a set of ordered pairs that graphs to a line. There's a couple special solutions to linear equations that we talked about. The x-intercept is the solution to the equation of the form x sub 0 comma 0. Assuming x is our horizontal axis, this is also called the horizontal intercept. The y-intercept is the solution to the equation of the form 0 y sub 0. Again, assuming that y is the vertical axis, this point is also called the vertical intercept. It turns out that a horizontal line has no x-intercept and a vertical line has no y-intercept. Let's work an example highlighting some of these concepts. Let's sketch the solution set to the equation 5x minus 2y equals 10 after first finding the horizontal and vertical intercepts. Well, the horizontal intercept is the point where the line crosses the x-axis. All points on the x-axis have a y-coordinate of 0. So I know that the y-coordinate of this point is going to be 0. Looking at my equation, if I replace y with 0, I'm left with the equation 5x equals 10. I can solve that in my head. X is 2. So the horizontal intercept is the point 2, 0. What's the vertical intercept? Well, the vertical intercept is the point where the line crosses the vertical axis, which in this case is the y-axis. Every point on the y-axis has an x-coordinate of 0. So I know that the x-coordinate is 0, I need to compute the y-coordinate. Again, looking at my equation, if I replace x with 0, I'm left with the equation negative 2y equals 10. I can solve that in my head. I get y equals negative 5. So the vertical intercept is the point 0, negative 5. Just a quick reminder before I move on, if it helps you to be successful to get out some scratch paper when making these calculations, please do that, because what we want more than anything is for you to be successful. Alrighty, I have now computed my two intercepts. I have the point 2, 0, and I have the point 0, negative 5. So I can get out my straight edge, and I can connect these 2 points with a line because I know that the solution set to a linear equation is indeed a line. So when I connect these 2 points with a line, I get something that resembles this. Before I leave, let's check another point on the line and make sure that it does satisfy the equation. So it's looking to me like one of the points on the line is 4, 5. Let's make sure that satisfies our linear equation. If x equals 4 and y equals 5, then the variable expression in our equation, 5x minus 2y, becomes 5 times 4 minus 2 times 5. 20 minus 10 guess what? That's 10. This point does satisfy our equation. One of the most important ideas when discussing lines is the idea of slope. If x sub 1, y sub 1, and x sub 2, y sub 2 are 2 points where x sub 1 does not equal x sub 2, then the slope m between the 2 points is defined by the formula m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Holy smokes, there's a whole lot of words to memorize there. I think we'll just work on memorizing the formula. The formula is m equals the difference in the y coordinates over the difference in the x coordinates. One thing you need to make sure is that when you calculate these two differences, you use the same order for both coordinates. The expression y sub 2 minus y sub 1 is commonly called the rise between the 2 points. Positive rises indicate upward movement and negative rises indicate downward movement. The expression x sub 2 minus x sub 1 is commonly called the run between the 2 points. Positive runs indicate rightward movement and negative runs indicate leftward movement. We frequently refer to slope as rise over run. Now, what makes a line linear is the fact that the slope is constant. So let's talk about lines and slope. Lines have constant slope. That is, the slope between any 2 points on a given line is the same regardless of what 2 points you pick. The only exceptions to this rule are vertical lines, and the reason vertical lines are an exception is because vertical lines have undefined slope. Alrighty, let's ask a few quick questions about the line shown here. First thing I want to notice is that my variables are not y and x, they're d and t. I need to keep that in mind when I'm answering questions about this line. The first question is, what is the slope of this line? Well, what I need to do is identify 2 points on the line. Here's the point -4, +5. Here is the point -2, 0. And figure out what is the rise and the run from one of these points to the other point. If I start at the top point, I need to go down 5 units. D is decreasing by 5. A decrease by 5 in our vertical variable corresponds with a rise of -5. Now to get over to my second point, I also need to move right 2 units. T is increasing by 2. An increase of 2 in the independent variable corresponds with a run of 2. Since slope is rise over run, the slope of this line is m equals -5 over 2. The next question is, what is the horizontal intercept? The horizontal intercept is the point where the line crosses the horizontal axis, which in this case is the t-axis. The line crosses the t-axis at the point -2, 0. So the horizontal intercept is the point -2, 0. What is the vertical intercept? The vertical intercept is the point where the line crosses the vertical axis, which in this case is the d-axis. The point where the line is crossing the d-axis is the point 0, -5. So the vertical intercept is the point 0, -5. Now let's talk about some intuition that you need to develop about slope. There's things you need to really understand in terms of implications about the sign of the slope and the magnitude of the slope. Lines with positive slope rise from left to right. We call these increasing lines. Remember, when you're reading a graph, you always want to read the graph from left to right. Lines with negative slope drop from left to right. We call these decreasing lines. Lines with a slope of 0 are level from left to right. We call these horizontal lines. What about magnitude of slope? When comparing the steepness of 2 non-vertical lines, the line that is closer to horizontal is the line whose slope is closer to 0. Let's say that, but in the opposite direction. When comparing the steepness of 2 non-vertical lines, the line that is closer to vertical is the line whose slope has greater absolute value. Or you might think of this as the line that is closer to vertical is the line whose slope has greater magnitude. Let's do a practice problem highlighting this intuition you want to have about slope. The slopes of the 5 lines graphed in Figure 1 are indicated in Table 1. which line has which slope. Now, something you might notice about this graph in Figure 1 is that there's no scale. That's deliberate. The point of this problem is for you to sort out what has positive slope, what has negative slope, which slopes have the greater absolute value. If we put a scale there, you might just count squares and figure out what the slopes are of all 5 lines and then answer the question. That's not what this problem is about. It's about slope sense, slope intuition. You know, I see a whole lot of lines in Figure 1. I'm going to work some computer magic that you couldn't do at home. I'm going to get rid of 2 of those lines. I'm going to lose the vertical and horizontal axis. I'm also giving the lines some letter names so that people that have a little bit of trouble distinguishing colors will be able to know which line it is that I'm referencing. Now, in my table, I see 2 negative slopes, a slope of 0, and 2 positive slopes. So I think the first way I'm going to break these lines apart is I'm going to think about the signs on the slope. Let's start with the slope of 0. Lines with a slope of 0 are horizontal. Line A is horizontal. So which line has a slope of 0? That would be line A. I think positive slopes are maybe a little easier to work with than negative slopes, so let's figure out which lines have the slopes of 1 and 4. Lines with positive slope increase from left to right. Line B is increasing from left to right. Line C is increasing from left to right. So those are the 2 lines that have positive slope. One of the lines has a slope of 4, which is a greater number than a slope of 1. The line that has the greater value of its slope is the steeper of the 2 lines. The steeper of the 2 lines is C. So it must be the case that C is the line with a slope of 4 and B is the line with a slope of 1. That leaves D and E. Well, we have 2 negative slopes left in our table. D and E better both be decreasing lines because decreasing lines have negative slope. From left to right, line E is in fact decreasing. And from left to right, line D is in fact decreasing. So the slopes of both of these lines are in fact negative. Line D is clearly the steeper of the 2 lines. The steeper the line, the greater the magnitude of its slope. The steeper the line, the greater the absolute value of its slope. -5 has a greater absolute value than -2. So the slope of -5 goes with line D, and the slope of -2 goes with line E. There are 3 forms for the equation of a line. The standard form is number times x plus number times y equals number. ax plus by equals c, with the condition that a and b cannot both equal 0. We've already worked an example of an equation that was written in standard form. There's a couple times that it's pretty common to work with standard form. When you're looking for both the horizontal and vertical intercept, it's actually easiest to work with lines that are written in standard form. Also, frequently, in application problems, standard forms for equations of lines are what naturally emerges from the statement of the problem. Now let's look at the slope-intercept form for the equation of the line. Y equals mx plus b. M is the slope of the line, and the point 0b is the vertical intercept of the line. Sometimes it's easiest to graph a line when it is manipulated or given in the slope-intercept form. Let's go back to our question about D and T. We already answered the question about what the slope of the line is. We saw that to get from this top point to this lower point, we needed to rise -5 and run 2. So the slope of the line is -5/2. We also talked about the fact that the vertical intercept is the point 0, -5. That means in my slope-intercept form, the letter that we call b has a value of -5. Since my slope-intercept form is y equals mx plus b, but in this problem, the vertical variable is d and the horizontal variable is t, I need to come up with an equation of the form d equals mt plus b. Well, I have all the information I need. The equation of the line is d equals -5/2 t plus negative 5, which simplifies to minus 5. Now let's talk about point-slope form. In point-slope form, m is the slope of the line. The point x sub 1, y sub 1 is any fixed point on the line. Let's find an equation for the line that passes through the points negative 3, 7 and 11, negative 17. To use point-slope form, I need to not only know a point on the line, which I've got those aplenty, I also need to know the slope of the line. So I'm going to begin by calculating the slope of the line. Let's assign x sub 1, y sub 1 to the point negative 3, 7, and x sub 2, y sub 2 to the point 11, negative 17. I could have made the assignment in the other direction. I just quickly made an arbitrary choice to assign the points in this manner. Our slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You might be wondering why I'm using the letters x and y. The problem didn't specify which variables to use, and so again, I just kind of made an arbitrary choice to use x and y. X and y are sort of the traditional algebra letters, and me being the traditional kind of guy I am, that's the way I went. Now let's take our values and plug them into our formula. Plugging our values into our formula, what we get is negative 17 minus 7 over 11 minus negative 3. Now I want to have a lot of room to write my equation, so I am going to go ahead and do this calculation in my head. The numerator simplifies to negative 24. The denominator simplifies to 14. 24 and 14 both have factors of 2 in them. So when I factor 2 over 2 away from the fraction, the numerator is going to leave behind 12, and the denominator is going to leave behind 7. But since I'm dividing a negative by a positive, the slope is going to come out to be negative. Now I need to use point slope to get the equation of the line. Since I've already, in my slope formula, decided that negative 3, 7 is the point x sub 1, y sub 1, I think I'll go ahead and use that as my point in point slope. Point slope says you subtract from y the y coordinate of your given point, and that equals the slope times the result that you get when you subtract the x coordinate of the given point from x. So this gives me y minus 7 equals negative 12 sevenths times x plus 3. So y minus 7 equals negative 12 sevenths x plus negative 36 sevenths. So when I go ahead and add 7 to both sides of the equation, that's equivalent to adding 49 sevenths to the right side of the equation as well as the left, and I'm left with y equals negative 12 sevenths x plus 13 sevenths. Now, I see some freaky numbers in this equation, so you better be sure that I am going to go ahead and check the other point in my equation. You know what? I'd be checking the other point even if I didn't see these freaky numbers in the equation. So our proposed equation is y equals negative 12 sevenths x plus 13 sevenths. Let's check the point 11, negative 17, the point that I didn't use to find the equation. If x equals 11, then the value of y is negative 12 sevenths times 11 plus 13 sevenths. Now, as I mentioned, I find these numbers quite freaky, so I think I'm going to get out my calculator so I just don't completely freak out. So let's see. I need to take negative 12 sevenths and multiply by 11. I'm going to be careful and put the negative 12 sevenths in parentheses. So here's my 12. Let's change it to negative. Divide by 7. Close the parentheses. Boy, the numbers are just getting freakier and freakier. We need to multiply this by 11. I'm not seeing a whole lot of hope that we're going to end up with negative 17, but let's keep going. Plus 13 divided by 7. Holy smokes, as if by magic, it really did work out that y came out to be negative 17. The point checks. Let's state our conclusion. the equation of the line is indeed y equals negative 12 sevenths x plus 13 sevenths. Let's go back to this idea about magnitude of slope. Remember that I talked about when comparing two slopes, the line that has the greater absolute value for its slope is the steeper of the two lines? A necessary consequence of that is that two non-vertical lines are equally steep if and only if their slopes have equal absolute value. Well, what if the lines also had slopes with the same sign? Same sign means either both lines are increasing or both lines are decreasing. If you have two increasing lines with the same slope, what are those two lines? They're parallel. Two non-vertical lines are parallel if and only if their slopes are equal. So let's find the equation of the line that passes through the point 2, 6 and is parallel to the line with the equation y equals negative 3t minus 2. First thing I'm noticing is that I know the slope of this given line. This line is written in slope-intercept form, so the slope is the coefficient on the independent variable. The independent variable is t, its coefficient is negative 3. So the slope of the given line is negative 3. So the slope of any line parallel to this given line is also negative 3. So there's our starting point. The slope of the parallel line is m equals negative 3. We also know a point on the line. A point on the line is t sub 1 y sub 1 equals 2, 6. I have all the information I need to use point slope. In this case, the point slope is going to be y minus y1 equals m times t minus t1. Plugging in my known values, that gives us y minus 6 equals negative 3 times t minus 2. So y minus 6 equals negative 3t plus 6. Adding 6 to both sides, y equals negative 3t plus 12. Let's check this answer. I think a graph is a good way to check this answer. I've gone ahead and had the computer draw the given line for us, y equals negative 3t minus 2. What I want to do is, I want to graph the line y equals negative 3t plus 12 and establish two things about this line. I want to make sure that it's parallel to our given line, and I want to make sure that it passes through the point 2, 6. Usually, when I have slope-intercept form, I begin drawing my line by drawing the vertical intercept. Unfortunately, in this problem, the vertical intercept is the point 0, 12. I cannot go up to 12 on the y-axis the way the y-axis is currently scaled. So I'm going to search for a different point to use as my initial anchoring point. In my head, pretty quickly running through possibilities, I can see that if t is positive 4, y is going to be 0. So I'm going to begin drawing this line by using the point 4, 0. Now I have a slope of negative 3. I can think of negative 3 as positive 3 over negative 1. Rise positive 3, run negative 1. Up 3, left 1. I also could think of negative 3 as negative 3 over positive 1. Rise negative 3, run positive 1. 4 points, that should give me a pretty good line. So I get out my ruler. And by golly, I did draw myself a parallel line. Let's make sure that this line is going through the point 2, 6. 2, 6. We have this problem nailed. Let's go on to the next problem. Let's recall that if the product of the slopes of two lines is negative 1, then the lines are perpendicular. Two non-vertical lines are perpendicular, in fact, if and only if the slope of one is the opposite reciprocal of the slope of the other. When you multiply opposite reciprocals, the result is negative 1. So let's work a very similar problem to the one that we just worked. The only difference is, this time, let's find the line that is perpendicular to y equals negative 3t minus 2 and passes through the point 2, 6. Well, as we discussed earlier, the slope of the line, y equals negative 3t minus 2, is negative 3. Perpendicular lines have opposite reciprocal slopes. So the slope of the perpendicular line is m equals positive 1 over 3. Now, I've worked a couple of examples showing you how to derive the equation of a line using point slope. We showed you another way that you could derive the equation of the line. Thinking about slope-intercept, I know that the equation of the perpendicular line must have the form y equals 1/3 t plus b, because the slope-intercept form for the equation of this line is y equals mt plus b, and I know that m is 1/3. I also know that the point 2, 6 is on this line. So since y equals 6 when t equals 2, what I can do is I can replace y with 6 in my equation, I can replace t with 2 in my equation, and I can solve the resultant equation for b. b is going to be 6 minus 2/3. Let's see, that is 18 minus 2/3, which is 16/3. 16/3 equals b. It appears that the equation of the perpendicular line is y equals 1/3 t plus 16/3. Let's check this. Let's check it with a graph. I've already had the computer draw the given line, y equals negative 3t minus 2. Let's draw the line y equals 1/3 t plus 16/3 and make sure that it satisfies the two properties stated in the problem. I'm not going to start with my vertical intercept because when I replace t with 0, the value of y comes out to be 16/3. I don't want to plot points where both coordinates are not integers, or at least even one of the coordinates is not an integer. So let's see if we can come up with a point where both coordinates are integers. I'm going to be a little sneaky. We're trying to show that this line passes through the point 2, 6. Let's make sure that 2, 6 satisfies this equation. If I replace t with 2, what do I get for y? I get 2/3 plus 16/3. That's 2 plus 6, which is 18 over 3. Guess what? 3 goes into 18 6 times. The point 2, 6 does satisfy this equation. So I can use 2, 6 as my anchoring point. Now I want to draw a line with a slope of 1/3. I can think of 1/3 as 1 over 3. That would be a rise of 1 and a run of 3. But you know what? If I make another rise of 1, I'm off the grid. I don't want to go there, so let's think of 1/3 as negative 1 over negative 3. Down 1, left 3. Down 1, left 3. Down 1, left 3. Time for the straight edge. Let's connect the dots. We already established that this line does pass through the point 2, 6, and by golly, these two lines surely do look perpendicular. So I'm almost 100% sure that we came up with the correct equation. Let me remind you about something about checking perpendicular lines. When you draw perpendicular lines and the scales are mismatched, they don't look perpendicular. So if you're graphically trying to visually establish perpendicularity, make sure you use an equal scale on both axes. All right, now let's talk about a couple of special types of lines. I think vertical lines are pretty special. In an xy coordinate system, the graph of x equals c, where c is a constant, is a vertical line with x-intercept c, 0. One thing you need to remember about vertical lines is that they have undefined slope. Horizontal lines, they're pretty special as well. In an xy coordinate system, the graph of y equals c, where c is a constant, is a horizontal line with a y-intercept of 0, c. You need to remember that horizontal lines have a slope of 0. So let's summarize all this slope business. Increasing lines have positive slope. Decreasing lines have negative slope. Horizontal lines have 0 slope. Vertical lines have undefined slope. Non-vertical parallel lines have equal slope. And perpendicular lines have opposite reciprocal slopes, provided that neither line is vertical. I'm going to finish up by asking a series of multiple choice questions. This is a place where it would be a really good idea if every single time you see a new question come up, if you were to freeze the tape and see what you think the answer is before you hear my explanation. It would be a good check for you. So our first question is, which line might be parallel to the line with the equation y equals negative 2x plus 17? Well, the line y equals negative 2x plus 17 has a slope of negative 2. So our parallel line also has to have a slope of negative 2. We need to find a line that decreases from left to right. There's only one line that fits the bill. That is line C. Which line might have equation x equals 4? Lines with the equation of form x equals 4, assuming you're working with an xy axis system, are vertical lines. D is the only vertical line. So D is the line that might have equation x equals 4. For example, this could be the point 4, 0. This could be the point 4, negative 3. This could be the point 4, 2. By George, what do those 3 points have in common? X equals 4. Which line has undefined slope? Well, this is kind of sneaky of me. It's the same line as we just were examining. Vertical lines have undefined slope, so that would be line D. Which line might be perpendicular to the line with equation y equals 5x minus 2? Y equals 5x minus 2 is a line with a slope of 5. Perpendicular lines have opposite reciprocal slopes, so we're looking for a line whose slope is negative 1/5. Lines with negative slope decrease from left to right. Only one line fits the bill. That is line C. Which line is perpendicular to the line with equation x equals 7? Well, as we were just discussing, lines with equations of form x equals a constant are vertical. What kind of line is perpendicular to a vertical line? That would be a horizontal line. So we're looking at line A. Which line might have as its equation y equals 3x minus 2? Well, the first thing I notice about this equation is that it graphs to a line whose slope is positive 3. I'm looking for a line that increases from left to right. The only line that increases from left to right is line B. But there's no way that line B has equation y equals 3x minus 2. Do you know why? Because the vertical intercept on line B clearly has a y-coordinate that is positive, and the vertical intercept on the line with equation 3x minus 2 is the point 0, negative 2. So we not only need a line that is increasing from left to right, we need a line that crosses the y-axis below the x-axis. There is no such line. This was a trick question. None of the above could possibly be y equals 3x minus 2. One last question. Assuming the same scales in all 4 pictures, which line's slope has the greatest absolute value? Well, let's toss out a couple of them right away. There's no way the answer to this is D, because line D has undefined slope. If you have undefined slope, you certainly can't have the greatest absolute value. We also can toss out line A, because the slope of the line in line A is 0. So I just know that the other 2 lines must have slopes with greater absolute value. Now line B increases from left to right, so it has positive slope, and line C decreases from left to right, so it has negative slope. Well, that's fine and dandy, but that's not the issue in this question. The issue in this question is which line has a slope with greater absolute value. That's the line that's steeper, and clearly line C is quite a bit steeper than line B, so the answer to this question is line C. That does it for my quick review about the algebra of lines. Now Candace is going to follow working some applications.